Working with Chapter 9 problems today, I'm going to start with number 4. After reading through this problem, I can see that I'm going to be looking for a 2-sample z-test. I'm comparing the, difference in the 2-sample means, and I want to see if it's less than the 10. So what I'm going to do is I'm going to hit Stat on my calculator. I'm going to scroll to Tests. I'm going to find my 2-sample z-test. And once I find the 2-sample z-test, I'll hit Enter, and then I'm going to be entering this in Stats because I have all the statistics on it. If it was a list of data, then of course I would enter it in as a list data. We are going to have to adjust for this minus 10. We're going to have to adjust here. If it's just a difference of 0, there will be no adjustment. So how I'm going to do this adjustment and all the other problems so that I can get my calculator to work this for me, I'm just going to add this number to both sides so that I'm really looking at this mu 1078, and I'm just subtracting 10 from all those values and then comparing them and making them, in effect what I'm doing is just trying to see if they compare to 0, which is what my calculator wants it to do anyway. So for my calculator, my entries are going to be this sigma 1 is going to be 1.1. That's my standard deviation for the first one. Then I need my sigma 2, and that's my standard deviation for the second one. That is 2.0. Then I need my mean for the first one, x bar 1, and that is 108.6. And here is where I'm going to do I'll go ahead and put my n1 in because it's next, sorry. That's 126. And then when I go to key in my x bar 2, that's where I'm going to do my adjustment. I'm going to do this adjustment, and you can actually key in 121.9 minus 10, and it will go ahead and crunch that number for you. Not that I can't do it in my head, but just let it work for you. N2 is going to be equal to 126, and our test is going to be whether or not it is less than mu2. And then you're just going to scroll on down to calculate, hit enter when your cursor gets on calculate, and you should get these values for both the z and your p. And then of course I've chosen the appropriate conclusion to this problem. There is actually, because the p value is 0, that just means the probability of this difference being less than negative 10 is virtually 0, so they're saying, yeah, you definitely reject the null. There really is data that suggests that the true average exceeds that of the other one by far. And of course we could see that from the data, but we didn't know if it was statistically significant. The next one is just a confidence interval. You're going to enter these same values that you did before, but you're just going to do a different test on it. You're going to do stat. You're going to scroll to tests. You're going to 2-sample z-interval because that is what you're looking for. And of course, enter in stats. And if you're lucky, your calculator will already have all these values in there, and you can scroll on down to the bottom and then just hit enter. So we do have to adjust for the minus 10 because my calculator gives me a 3.699 and a 2.901, and then I have to realize, hey, I subtracted 10 off all these values to see if it was less than 10, so I've got to put that back in there. And so that was how I got the negative 13, but you should get those values there. Reading through problem 9, I noticed that this one is going to be a t-test. So I'm going to be looking for a 2-sample t-test. And the buttons on this. I'm going to hit Stat on my calculator. I'm going to scroll over to Tests. I'm going to find my 2-sample t-test, and I am definitely going to enter the statistics on this because there they are above. Keying all of this in, what I key is for x1, I'm going to have 24.75. For my standard deviation for x1, that's going to be 0.162. My n value for sample 1 is 8. The mean value, x bar 2, is going to be 20.98. And standard deviation for this one is going to be 0.250. Number in my sample is 5. So let's see. And I am doing this one just to see if it's actually different. So that's why we have this particular test, just to see if it's different at all, see if that difference is different. It revolves about 0, so my calculator is pretty happy with this. I don't have to do any adjustment. I get that value for t and that value there for p. And there is my 2-sample t-test. I'm going to do problem number 8 next, just because I'm going to kind of trick my calculator into doing this problem for me, even though it's not necessarily straightforward. Question number 8 is a 2-sample t-test once again. Let's do the A part and let's key in all our values because we do have some values missing, but that'll be okay because we're just looking for degrees of freedom, and you can actually use the formula for this, but I prefer to trick my calculator into it. I need the standard deviation for sample 1, that's a 4. Number in sample 1, that's a 10. Sample standard deviation, that would be a 6. The number in that one is also a 10. Now I just chose any test. It really doesn't matter which one it is. You'll get the same value for degree of freedom. And I forgot to mention the other. We're going to keep on our t-test. We're going to keep our values as pooled. You're lacking a mean, but it doesn't really matter because the only thing in your formula, if you're looking for degree of freedom, and degree of freedom formula looks like this. So if you'll notice, that formula doesn't have the mean in it anywhere. So it doesn't really matter what you put in here for mean. I just kind of put in something reasonable that could have a standard deviation of 4. So what I actually put in, I just randomly picked a 10, and then I randomly picked a 12. You could have put a 10 and a 10, 12. It won't matter because all we're looking for is the degree of freedom. Now what you'll get for this, if you punch in all these buttons, you'll get your degree of freedom. Your calculator will tell you that the degree of freedom is equal to 15.68, and because our degree of freedom is always 1 less, just take that to be a 15, and you'll do that on every single one of these, just randomly. I just left them all the same, 10s and 12s, but it doesn't matter. You can put 100 and 1200. It really doesn't matter. So you can trick your calculator into doing this, or you can take these values and key them into the formula, and you can crunch it that way, and you'll still get the same value, 15.68, and then you'll say that it's 15. After reading through this problem, I see that I'm going to have a t-test, but I first need to put my data into my list 1 and list 2. So you're going to hit Stat, Edit. I put YF into L1, so then this was my L1. I entered in that data, and then I put this in L2. And then what I did was I did a stat test. And then I'm going to a 2-sample t-test using my data. So I just wanted to give you an example of one where I use my data. I kind of like using the data. I mean, after the initial keying in of all those values and making sure I don't make a mistake keying them in. Once you do that, then it'll just say list 1, and you go, yep, L1, and L1 should usually be popped in there. If it's not, just hit your second key or your shift key, it's blue, And then you'll see L1, he's on the number 1 key. And then list 2 should be in L2. Frequency on each of these is 1 because I didn't have multiple listings that I made it calculate for me. So that's frequency 1. Frequency 2 is also 1. And on this one, I've already decided that I'm going to see if the difference is greater than 10. So I'm choosing the greater than mu naught. I am going to adjust my values on this. For all of those values, when I entered them into L2, because it was one of these where I'm looking at a difference of 10 and not 0, so add 10 to each of these. And then I'm going to compare it with the 0 that my calculator lets me do. When I did that, these are the values that I got for T and P. I usually like to do a p-value comparison. Let's see, my comparison number was, it's at the 0.10 significance level, alpha equal 0.10 significance level. So what this says is if it's anything less than 10%, if your p-value is anything less than 10%, you reject. And so it is less than 10%, it's the 3.79%, so I definitely rejected on this one. This one I had to read twice. If you read this question A, they don't ask you about comparing it to the younger, they're just asking you about the older. So this is a question I think was in a previous chapter, probably chapter maybe 6, I think it might be 7. Okay, I just wrote down what I entered in my calculator to get that confidence interval. And the next part of this is which hypothesis test that we're going to be using, and we're going to see if the difference is greater than 0. And that is using mu1 to be, I think, they want mu1 to be your elderly, so it's going to be the elderly minus the younger. So I choose that one to be mu1. These are the values that I keyed into my calculator. This is just a normal 2-sample t-test that I'm used to working with. And these are the values that I keyed in. They're just the ones that they gave me. I got my test statistic. This t equals 1.145. I also got a p-value of 0.1293. They wanted this to be at the alpha equals 0.05 level, so what that says, if your p-value, and I usually like to use p-value, so I just go ahead and do it, even though they have me calculate my test statistics, I go, yeah, whatever. My p-value is 0.1293, and the alpha says that if it's less than 5%, or if p is less than 5%, reject. Well, p is greater than 5%, so I failed to reject. Now, calculating this t-value right here that you're supposed to be able to compare it to, what I do for that is I go ahead and run my regular statistic. I get my degree of freedom from my calculator. It gives me my p, and it also gives me my degree of freedom. The degree of freedom that the calculator gave me on this one was 41.6, which means I'm going to use a degree of freedom of 41. If I look it up in my tables, or if I do inverse t and just say I'm looking this up at the 0.05 level, which is my alpha value, and then my degree of freedom, and then I will get the 1.6829. I actually get negative 1.6829, but I know how the t-tests work, and it's going to be 1.6829 on the positive on the right, and then the negative value that would be on the left. Since I'm only testing the greater than situation, the less than is none, and I am finished with number 15. And yes, I know the dog was chewing on the squeaky toy, and that is what that sound was.